Okay, the mean height of a hobbit is 42 inches. I underlined it because we definitely need to know what the mean is. With a standard deviation of 4 inches. And then there are currently 500 hobbits in the Shire. Alright. Assume the data is normally distributed using the 68, 95, 99.7 rule to answer the following questions. So A, what is the median height? And B, what is the mode height of the hobbit? So for these, you need to remember that the mean, mode, and median, all the ends, the central tendencies of measure, are the same. Okay, so if the mean is 42, and the mode is 42, so how many hobbits have a height that is within 1 standard deviation from the mean? And how many hobbits have a height that is within 2 standard deviations from the mean, round to the nearest hobbit? So this is where our rule comes in, 68, 95, 99.7. If we draw our normal distribution, we can see it, but this rule tells us that 68% is within 1 standard deviation. And then 95% is within 2 standard deviations. And then 99.7, that's the 3, but we just need within 1 and within 2. So we need to figure out 68% of what? How many? How many hobbits are there? That's this number that we haven't used yet. And we actually are never going to use what the standard deviation actually is. But there's 68% of the 500. And if you use Desmos, you can just type it in. Or if you're looking at my copied notes, it's going to be old school on there. So 68% of 500 is, I just forgot, 340. So 340 are within 1 standard deviation. Now we need to know how many are within 2. So that's 95% of the 500. Maybe we're going to get a decimal since it's telling us to round. Let's see. Nope. So 475 are within 2 standard deviations.